Hey Royals, sorry, I think I got cut off at the last video. I want to do just one other example where we don't know how many solutions there are. I think it is labeled example C. Example B wouldn't have been cut off. Have a look at example B on your own. It's going to have almost the same conclusion as C. Imagine we are given triangle, let's call it DEF, where angle D is 50 degrees, side length D is 10 meters, and I don't know, well, I guess we'll say that side length F is 7 meters. So I'll just draw myself a rough sketch to organize what's given here. Call this DEF. Angle D is 50 degrees, side length D is 10 meters. Side length F is 7 meters, and this looks okay to scale here. Then I am set up to use the sine law to try to find angle F. And I'm wondering if there is one solution, two solutions, or no solutions. To use the sine law, I say that the sine of F divided by 7 meters would equal the sine of angle D divided by 10 meters. This gives me if in grade 10 you would have done this all in one step, I'm going to suggest that you not do that. You're in grade 11 now. Let's solve for what 7 sine 50 degrees divided by 10 is. Even just approximating it, I think will help us. Because I would like to draw a diagram in standard position here. Keep about 4 places of accuracy for ratios. Now, going right to the answer for F, my calculator will only tell me at most one answer, and then it's really easy to forget to check for the second answer. So in standard position, I draw a triangle, or sorry, I draw a circle, and I try to figure out where on this circle the ratio of the y value to the radius would be about 53%. This means I go about 54% of the way up. And it tells me there's 2 solutions. These 2 solutions, one is in the first quadrant, one is in the second quadrant. The reason why there's no ambiguous case for the cosine ratio is if your cosine law is if your cosine ratio is positive, your angle is either in the first quadrant or the fourth quadrant. And an angle inside a triangle cannot be in the fourth quadrant. If your cosine ratio is negative, your angle is either in the second or the third quadrant. Angles in the third quadrant are reflex. They're bigger than 180 degrees, and angles inside triangles cannot be reflex. The problem, I suppose, with the sine law is that sine ratios are positive in the first and second quadrant. In the first quadrant, you have acute angles. In the second quadrant, you have obtuse angles. It is possible to have both an acute and an obtuse angle inside a triangle. Let's see what happens in this case. I ask my calculator, I'm pretty sure that's F1. What is the inverse sine, or it's going to be about the inverse sine of 0.5362. And if I've kept this value in my calculator, I don't really need to worry about rounding off as much. For my calculator, I just say sine inverse and then hit equals. You might have to hit your answer button. But I get about 32 degrees. Okay. Now, if I am curious about the possibility of a second solution, 32 degrees, then I will say I have a potential for a second solution here, F2, which would be the supplement of that angle. I see it right here on my sketch, 180 degrees minus 32 degrees. And that would give me, what, about 148 degrees? Can you see the problem with this second solution versus the Albert and Bell situation? I'm wondering if you could see the issue with the diagram. Try swinging that 10 meters around. It's not going to touch at a second point over here. And if you take a look at these 2 angles that we have, this is usually the most dangerous if I just ask you to find the values of F, because sometimes students won't see the issue. If I ask you to calculate the third angle, E, then that's a bit of a hint actually for you, or a bit of a help for you, because in the first situation, I would get E is going to be 180 degrees minus 50 degrees minus 32 degrees. And what's that? 130, about 102 degrees. So no problem there. E2 in this case would be about 180 degrees. I would subtract the 50 degrees for that angle, and then I would subtract the 148 degrees. If you didn't see the problem before, can you see it now? Before I go to my calculator and say 180 minus 50 minus 148, and I get that the angle inside the triangle is a negative angle. We now know there are such things as negative angles, but they don't exist inside triangles. This angle right here is too big to fit inside. So there is only one solution here. For your assigned work for lesson 4.7, you should try to solve the triangle and then see if there is a second solution, see if you have room for a second solution. I've made analogies to quadratics and said, like quadratics, triangles where you're using the sine law to solve for an angle could have 0 solutions, 1 solution, or 2 solutions. Well, in lesson 4.8, very much like how we developed a discriminating tool for quadratics to tell how many solutions there are, we're going to develop a discriminating tool to figure out how many solutions there are for a triangle. Okay.